Hello, folks. We're going to look today at a couple of things that I like to label limits and footprints. And I think you'll find these really interesting ways of looking at and assessing sort of the state of the planet right now as we see it. So let's start off the quote here. This comes from the textbook I used last year, Humans and Landscape. The enormous success humans have had in expanding Earth's carrying capacity. So we talked a lot about that this past week and talking about tragedy of commons, carrying capacity, etc. So we've had a lot of success in expanding carrying capacity. So the enormous success we've had, particularly as our numbers and our material consumption have increased over the past 350 years, talked about that a lot, raises a question: can we keep going, or are we going to encounter limits to Earth's carrying capacity as all other life forms do? So I want you to pause the video and reflect on that question right there. Can we keep going? So this question lies at the heart of debates over population, agriculture, economics, sustainability, conservation, all kinds of different things. But to get at, can we keep going as we are? We have been successful, as this quote indicates, at expanding the Earth's carrying capacity for humans. But what used to seem impossible, we have now managed to make happen. If you remember, going back to Paul Ehrlich and the population bomb in the 1960s, where he made popular this idea that there are limits to the amount of growth that we can pursue, that the human population is going to see those limits, reach those limits, and that there will be devastating consequences, he predicted, because of that, mass famines and war and disease that would come about from that. Now, a number of things, as we talked about, didn't play in Ehrlich's favor. For one, the year he published that, 1968, was the exact same year that our population growth peaked and our growth rate began to decline after that. So that was one factor. Two, he underestimated our ability to expand our carrying capacity by expanding our agricultural production, in large part because of something called the Green Revolution, our ability to greatly expand the amount of agriculture we're producing in the same space, which we'll talk about later in the course. Nevertheless, he seems to be striking on something right in that there are limits to things. He was a little bit sensationalist in how he presented it, but the idea that there are limitations to exponential growth, that there are limitations to carrying capacity of ecosystems, we know this to be true. And so to what degree are we facing those limits in our lives and in the way that human societies function is a key question today. One important principle that undergirds this kind of thinking is often referred to as the precautionary principle. And it simply states that when an activity raises threats of harm to human health or the environment, precautionary measures should be taken, even if some cause and effect relationships are not fully established scientifically. In other words, even if we don't understand every aspect of what is happening, if the threat to humanity, to human society, or to the planet are significant enough to cause massive disruption, then we should act in a precautionary measure, in a conservative manner, in a way that errs on the side of safety and caution. And I like this little cartoon here as a good demonstration of that principle and idea. Many scientists have begun to look at this as an important principle to guide the way that we approach these kinds of challenges. So there are a lot of aspects of Earth systems that we don't fully understand yet. We understand a lot, now a whole lot more than we used to. There's a lot of things we still don't know, or that we haven't been able to fully quantify yet. But the inability to fully quantify how some of these processes work shouldn't prevent us from acting in a conservative manner when the potential negative consequences of failing to do so are significant. And that's the precautionary principle. So today's lecture, we're going to focus on two ways of measuring human impacts on the planet. And those are planetary boundaries and ecological footprint. And I think both of these have really valuable frameworks for helping us understand. And this is sort of putting the book in on this first this first section, well, I guess this is our second unit, first being the introduction, the second unit being sort of looking at what are all of these processes that make it challenging for us to address environmental issues. I think it's a nice bookend for that because this helps us get that kind of planetary ecological framework. So first off, we're going to look at this idea of planetary boundaries. So you read about this in your reading, but planetary boundaries, essentially what we're doing here is scientists are applying rigorous science, so taking the best science we have in a variety of different fields, from physics to chemistry to biology to geology, and applying the precautionary principles. So this idea that there are some topics like climate change or like the ozone layer or like the nitrogen cycle or biodiversity that are so huge and so critical and have such potential to disrupt the way of life on this planet for many, many years to come. They're so important that we need to act conservatively to make sure that we're not going to cause permanent long-term harm to the planet or to human society because of that. So applying the best science we know on these topics with that precautionary principle in mind. And the way they're framing it is to define a safe operating space. And that's the key phrase right there. Safe operating space for human societies to develop and thrive based on our evolving understanding of the functioning and resilience of the Earth system. In other words, looking at the Earth system, if our goal is for human societies to thrive, then we need to identify a safe operating space around these key issues that are potentially issues of concern here. And part of this is the recognition that the Holocene era is the only era with humans in it. This is the only time when humans have thrived on this planet. So we want to make sure that we don't inadvertently push the Earth system out of a Holocene-like state. So the state of conditions that the world is in now, if you think back to our discussion about the architecture of the planet and Earth systems, the Earth, the system, the way that the Earth is functioning right now is great for humans. But we are in danger of, because of our actions and because of the ways that we're interacting with the world around us, pushing us out of a state that's conducive to human society's flourishing. So we want to be careful of that. We know we're impacting Earth systems in a big way, and that there are planetary level threats that are bigger than just ordinary environmental problems. These aren't just localized or regional problems, but there are ways that we're impacting the planet for the first time on a global or planetary scale, and we need to be cognizant of that. Once again, I think I said a little bit too much before asking the question. Would you pause the video here and answer that question down there at the bottom? Just give some of your quick thoughts on that. Why are we suddenly asking this question? This question being about how do we define a safe operating space for humanity? How are we asking that question? Why are we suddenly asking the question of how do we define a safe operating space? All right, moving along. So the planetary boundaries approach takes an approach of, and particularly or specifically, I should say, the people who came up, this comes from the Stockholm Resilience Institute, which is an institute in Sweden, full of top-notch scientists that really look at this. And they look particularly at 9 specific issues. And you see them listed there. We'll talk about them again in a bit. Again, 9 issues that are potential threats to disrupt a Holocene-like state on the planet. In other words, they have the potential to threaten the very Earth systems themselves. So they have attempted to quantify for each of these, and they haven't finished yet, still working on it, but quantify for each of these, what is a safe operating space? That's the green space there. So the safe zone, the green space, is where there's very low probability of crossing a critical threshold that would disrupt that system on a planetary scale. So you see a few of them in the green, though that changes in the next graph. We'll show you that in a bit. But safe zone, basically, we're still okay. We're doing good. The current trajectory we're on is acceptable for continuing to maintain a state of the planet in that respect that is conducive to human flourishing. Yellow zone, zone of uncertainty, allows for some gaps in scientific knowledge, but it acknowledges that we are beyond the safe zone, and we are heading towards increased danger of permanently disrupting the ecosystems around us in those areas. So you see a number of areas that we are in this zone of uncertainty where we're not really sure exactly where we are, but we know we are beyond the safe space at this point. And then the danger zone, where there's a much higher probability of devastating changes to Earth systems. And there's a few areas that we are indeed in the danger zone, knowing that there's a very high probability that we are currently, the actions we are currently taking will result in permanent long-term damages to our systems. So we look at that, and the best science put it to this is saying that there are some areas that that's the case for now. Note that boundaries are different than thresholds in the same sense that a fence before a cliff is different from the edge of the cliff itself. So the threshold is, think of it as a tipping point. That's the point where you step off the cliff. That's the point where the boulder starts rolling downhill, in which case it's unstoppable. That's the point that we can't change or turn back from. That's the threshold. That's the tipping point. The boundary is the idea of a boundary should be before the tipping point. We don't want the fence. There's no point in having a fence beyond the edge of the cliff. The fence needs to be before the edge so that we're protected. And of course, the closer the fence is to the edge of the cliff, the more risk it is of someone actually falling over. So the idea that we want to set boundaries in the safe area, but it's a little bit hard to know that. What is the safe area is a key question. Now, if you look at this next chart, this is the updated version. And they actually, if you look at the website of the Stockholm Resilience Institute, this old one is still the one that you mainly find, but they have just published 2 recent studies that changed some things on a few of the things that they're doing here. So particularly, they changed a couple things. So for one, they changed how they communicate about planetary boundaries. As you may notice here, there's no longer 3 different zones, green, yellow, and red. Instead, they have kept the green, the safe operating space, which really is the important one, right? If you're either safe or you're not safe, is the idea. And acknowledging that everything beyond the safe operating space, the further you go beyond it, the higher the chance of risk of tipping that system into a permanently negative state. So that's the idea. Instead of this zone of uncertainty, we know, and even in this old system, the zone of uncertainty we know to be beyond the safe space. We know we're beyond safe at that point. So this simply acknowledges the increasing level of danger the further you go beyond that, which seems from a communication standpoint to me to be a more helpful framework in terms of how you communicate. The other things that have changed is we have 2 novel entities was not quantified until this year. They came out with the planetary boundaries in 2009, but it took them until this year to quantify novel. So for novel entities, what they're talking about essentially are all the human-made chemical compounds that we're putting into the environment, plastics and toxic chemicals and other man-made chemicals that are going into the environment and influencing the natural world in significant ways. Well, they just quantified that and it didn't come out good for that. The other thing that changed, freshwater used to be in the green space, and that's because they look specifically at what's called blue water. In other words, lakes and rivers and aquifers, and those are okay. The status of our lakes and rivers and groundwater is good. However, our green water, which relates to the amount of water stored in plants and soil moisture, is bad. That's in a bad shape. So they have put that beyond the safe zone. So these are 2 new ones that are beyond the safe zone here. So these are the reports that just came out. One of them actually just in April. I'm recording this right now in May, so this just came out a couple of weeks ago. The other one in January, and both of these pointing towards new boundaries that have been crossed that are there. So very disturbing when you look at that. And let's take a look specifically at the different boundaries that they quantify here. So look at, starting at the top, freshwater change, that has to do with the availability and the usability of fresh water. Again, blue water being the freshwater resources that we tap into, green water being the amount of water stored in soils and in plant matter. And particularly soil water management seems to be in bad shape, and that soil is drying out on a global scale in a way that could disrupt the hydrosphere in a really significant way. Ozone depletion, that's an actual great success story. If you know anything about the ozone hole and the history of that, and I dig into this a lot more in my public policy course, where we talk about the Montreal Protocol. But this is actually probably the best environmental success story on a global scale, where we're talking about the ozone layer in the stratosphere, the atmosphere. Again, planetary scale, we're talking about the atmosphere here, one of the 4 Earth systems, and we were causing a disruption to the ozone layer. And the ozone layer in the stratosphere is good because that protects us from ultraviolet radiation. And we figured out what was causing it, for one, primarily chlorofluorocarbons and refrigerants and aerosols. And we figured out how to solve it by switching to other chemical compounds. And the world came together and all agreed to do so. If only we could do that on climate change, wouldn't that be great? Alas, we haven't, but we did around protecting the ozone layer, and that's in good shape. Atmospheric aerosol loading, they have not yet quantified on there. Ocean acidification, still in the safe zone, but you'll note just barely in the safe zone. It seems clear that we are approaching a boundary there in terms of the acidification content of the ocean. That's not good. Biogeochemical flows, nitrogen and phosphorus are in trouble. We have severely disrupted the biogeochemical processes related to how those nutrients are cycled throughout the Earth system. Novel entities, particularly plastics and other man-made chemicals. Land system change, obviously we have disrupted land use in significant ways through deforestation in many places, through pushing human development and disrupting ecosystems in major ways, and biodiversity loss significantly, as well as climate change. We know for sure we're out of the safe zone there and continuing to increase in risk as greenhouse gas concentrations continue to go up on that. So basically, this is just looking at, these are 9. Are they the only 9? Probably not. Are they really key and important? 9? Yes, absolutely. That seems clear. And they've been working really hard to quantify where we're at with each of these and are continuing to make progress. Again, but the last fall, 2021, when I did this class, they hadn't even yet quantified novel entities and didn't have the subcategory for green water. So continuing to make progress and adding new categories and continuing to update our scientific knowledge about each of these as well. Okay, I think I addressed this well. Note, and you saw this in the reading, some boundaries are actually more important than others. All 9 of these, really important because we're talking about planetary Earth systems. However, 2 in particular, climate change and biosphere integrity, scientists look at that and say, these 2 in particular have the potential to completely push the Earth out of a Holocene-like state. In other words, we've got the state of the Earth right now that is conducive to human society flourishing. Serious changes in one of these 2 will push the Earth out of that state and make the Earth significantly less habitable or uninhabitable or not conducive to human flourishing, human society flourishing. So climate change, biosphere integrity are particularly important, which is why all throughout this course, you will continue to hear climate change and biodiversity referred to again and again and again and get special attention, because when scientists look at what are the major environmental threats to the planet, over and over, these come up as the 2 most significant and most important ones to pay attention to. So those certainly are worthy of extra attention. There's some criticisms of planetary boundaries. Some say that the boundaries are arbitrary, which is relatively true. You know, why is 350 parts per million of carbon dioxide considered the level at which we're supposed to limit our carbon dioxide concentrations to? We're at 420, by the way. Why 350? Well, would 360 be acceptable? Is 340 too much? Who knows? There's a little bit of arbitrariness to that. But the idea being, let's take the best science we have. Let's add the precautionary principle. In other words, let's err on the side of being conservative and picking what we think is safe, given the best science that we know, and go with that. But some say, hey, these are too arbitrary, or too many unknowns, too many things that we still don't know about that. Over time, we're gradually understanding these unknowns better and better. But there's always things that we don't fully understand. Or humans can adapt and change, just like pointing to look, Paul Ehrlich got it way wrong in 1968. humanity figured out how to adapt, and we did. And we will continue to figure it out again. And I sure hope so. But that's an awful big hope to pin the state of the future on. Or there's uncomfortable implications to this, which there are, because there's not easy answers. Again and again in this course, we'll talk about that. There's not easy answers to these challenges. So if there's not easy answers, how do we address these challenges? I don't know. And then one other note on planetary boundaries is this idea of tipping points. So, you see this reflected in, what is it about this safe operating? It's this dotted line here. Like, what is this about this line here that makes it different? Why does it go from green to red after that? But tipping points are these sort of unknown trigger points that have the potential to happen and create a further sort of accelerating, cascading effect of moving us in a negative direction on these, with potentially unknown consequences. So a few examples of potential tipping points. West Antarctic ice sheet, for one. So this is pictured down here. So there's warming in the Antarctic. The planet is, on the whole is warming, but it's warming faster at the poles. So one of the consequences of that, of course, is glacial melt. So as the glaciers in Antarctica are melting, a lot of that water is running into the ocean. A lot of that water also is running through holes called moulins, and I should have put a picture of a moulin up here, down, and it's basically a big hole that opens in the glacier. The water flows into it and creates a hole all the way down to the bottom of the glacier, to the bedrock underneath it. And what it does is it creates a lubricating effect, where that water lubricates the rock underneath it and speeds the movement of the glacier toward the ocean. Glaciers are already moving toward the ocean very slowly, but that water that's running down underneath is speeding the movement. So a tipping point, at some point, there's likely to be a tipping point where enough water melts and goes down into those moulins, lubricating the glacier underneath, and that will speed up the glacier to a point where it tips and it just rapidly moves into the ocean. You can, the physics of this are not tremendously complicated to the point where we can't understand it, but we can intuitively understand how that would take place. Now, what's that tipping point? Who knows? Is that going to happen next year? It could. Or maybe it could be 100 years from now, or maybe it could be tomorrow. There's no way to exactly know that, but that could have very significant consequences, particularly from a sea level rise perspective, or slowing down of the streams in the ocean. So we have these heat currents in the ocean that transfer heat energy around. And one of the things we're seeing as we're getting more water melting off the glaciers of Greenland, that fresh water is slowing down the Atlantic current that moves heat transfer around the ocean. That could have significant effects for the climate, both in Europe and in North America, because it could slow down the heat transfer in the ocean. It's a lot more complicated than that. We don't need to go into the details of it, or drying out a rainforest. At some point, that loss of soil moisture that we just talked about in the Amazon, for example, could become so significant that it triggers a tipping point that moves in a way that we can't prevent the Amazon rainforest to a drying out and becoming a savanna. That would have severe consequences on a planetary scale, or cascading of overfishing too. At some point, you overfish too much, and the fish population can just never recover. What's the tipping point for that? It's a little bit hard to determine what exactly it is, but we know that it's there at some point. And so these are things to be extra cautious of. Again, this is where the precautionary principle comes into play, is the idea that there could be very severe consequences for transgressing some of these boundaries and some of these tipping points. And if we don't know exactly where they are, we should err on the side of safety. So question number 3, how can we use the planetary boundary approach to help address environmental challenges? What do you think of that question? Pause the video, give a couple thoughts there. All right, next concept I want to talk about, ecological footprint. What we're talking about here is the measure of the human impact on natural ecosystems compared to the Earth's capacity to meet these demands. And I love this picture of WALL-E as a great demonstration. Obviously, WALL-E, cute movie, we all love it. Very extreme example of this, but it helps visualize what we're talking about here. In WALL-E's world, the Earth is no longer able to keep up with the demands humanity has put on it, particularly the demand to deal with our waste, as you can see from this picture. So the Earth can't put up with it. We have too much waste. There's nowhere to put it. And so humanity has had to abandon Earth. Obviously, super fictional. Obviously, there's nothing even remotely like our current state that would look like this. But sometimes it helps to take the most exaggerated example you can think of as a way to visualize what we're talking about here. So in WALL-E's world, our ecological footprint is so enormous that humans have had to abandon the planet. Now, we're not in danger of getting there anytime soon, but you can see a trajectory here of a trajectory that is moving towards unsustainable levels of demands on the planet. Here's another way to visualize it here as well. So ecological footprint measures how fast we consume resources and generate waste. Resources like energy, like the space that we need, like wood, like food, all of these things. These are resources we use and we're creating waste. So it's how fast we're consuming those resources and creating waste compared to how fast nature can keep up with that, how it can provide for those new resources. Because God designed the planet in a great way to provide those resources for us. We have lots of energy resources, lots of food resources, lots of fiber resources that are available for humans to use. And many of those resources, now not all energy resources, fossil fuels we can't regenerate on any kind of time scale that's helpful for humans, but we have renewable energy resources that are infinitely regeneratable as well. So these things, nature can replenish these, but only at a certain pace, right? So and if you think back to what was the first finding on the Millennium Ecosystem Assessment that we did, that second class session, right? So if you remember that our demands have caused major degradation to ecosystems, was that first finding. Our demands of food, fiber, fuel, those demands have caused major degradation to ecosystems. And that's because of this right here. That's because the speed at which we're consuming resources and the speed at which we're generating waste, nature is not able to keep up with that. So the Earth's systems have not been able to keep up with the pace at which we have been using those things. So it's not, the problem isn't using resources. The problem is the rate of resource use that we've been able to have. And that's an important from a footprint perspective. So ecological footprint, we can think on this on several different levels. So one, on the personal level, what is my personal impact on the planet? My own choices for my lifestyle, what I eat, the size of house I live in, the way I transport myself around, what I buy. These kinds of decisions impact my own personal ecological footprint. Now, under ecological footprint, often you've heard of the term carbon footprint, no doubt. Carbon footprint is one component of an ecological footprint that deals with how much greenhouse gas emissions we emit, or carbon emissions. So I measure my own carbon footprint every year. I look at my personal carbon footprint. I also measure it for the college, by the way. So I measure those things. Carbon footprint is a subset under ecological footprint. It's one thing underneath that includes other stuff. So what's my personal impact on the planet? Societal level. There's a lot of different things within here, but how much does a particular organization like Houghton College, or a company, or a state, New York State, or a country, the United States, what does the footprint look like on each of those levels? And there's most large corporations now have a sustainability officer and measure their carbon footprint. This has become normal for large corporations. Chances are you work or you will work for a company that measures their carbon footprint. This is just something that's done now. Every country in the world measures their carbon footprint. That's part of the Paris Agreement. They measure their carbon footprint and they publish that. So this has become normal to do. So personal, what are my individual, sort of corporate, institutional, or country level, and think about it on a global scale. On a planetary scale, are we using resources at a sustainable rate? Would be fundamentally probably the most important question that's out there. So let's reflect on a few questions here. So first of all, here's a question for you to reflect on. What results when an individual, when a single person has an outsized ecological footprint compared to what the planet can sustain? So we know whoever lives here, their lifestyle is not replicable on a global scale. The 8 billion people on this planet cannot all live like this, unfortunately. We think that that's pretty obvious and true. So what results do we see? What are the implications of this? Pause the video and give a quick answer to that. So one obvious implication is there's always haves and have-nots, right? So if somebody is consuming more than their share of resources, that means there's fewer resources available for someone else to use and consume. So that's one obvious implication to this. Let's take this to the next level. Let's look at footprint by country. I know you can't read that, but the point is the overall. So this looks at countries. So each of those little lines on the bottom there are individual countries. It doesn't have every country in the world. It's got a chunk of them. And this is their ecological footprint of those countries. So you can see all the way down to the smallest footprint. I think that's Timor-Leste down there, up to the biggest footprint, which I believe is listed as Kuwait. And you can see there's some pretty big differences on here. In particular, look at the difference there. This arrow here is the United States, by the way. Not the absolute highest. This is in per capita, by the way. If you looked at just total footprint, I'm pretty sure the US would be #1. Per capita footprint, we're a little bit lower than some of the Arab Gulf states, but we're definitely the biggest of the major world economies. That's there. So US, look at the difference between US and Timor-Leste. Huge, huge difference. Now note, this line right here in blue is the world biocapacity per person. In other words, this is what the world can sustain. So some countries like the US are quite a bit above it. So reflect on this question. What results when a particular country has an outsized ecological footprint compared to what the planet can sustain? Pause and answer that real quick. So obviously there's some disproportionality here. If these countries over here are using up greatly more, demanding far more than what the planet can sustain, they're essentially borrowing from others, right? They're borrowing from these countries. These countries can't continue to develop if these countries are using the resources at an unsustainable rate. Or they're borrowing from future generations. They're borrowing resources to the extent that we're going to harm the ability of future generations to meet their own needs as well. So there are some significant sustainability concerns here and significant equity concerns here. Just because when you have countries that are far exceeding what the planet can sustain, it means either that there are other countries that are far below what they need to have a decent standard of living, and more likely, we are limiting the ability of future generations, both in our country and other countries, to be able to live in the same standard of living as we are. Simply because the earth can't sustain that. It's not possible for the earth to continue to sustain that kind of consumption. And last question, what results when the world average exceeds what the planet can sustain? Because that's where we are. There's the world average right there. As you can see, it's above the biocapacity. In other words, we're borrowing from the future in order to meet our standard of living now. So pause the video. What are the implications to that? Obviously, implications are not good. It means that and that gets to why we're exceeding these planetary boundaries. We're exceeding these planetary boundaries because we are taking more from the earth than it can replenish in the meantime. And in the process of doing so, we are hindering our ability to continue to live in a condition that is satisfactory, like we have now. I really like this chart here. So this chart looks at each of these dots as a country. Colors correspond to different world regions. On the x-axis, you see the Human Development Index. This is a measure of well-being that takes into account education and health and and I'm blanking on income. Education, health, and income. Everything above 0.8 is considered a high level of human development. We want that. We want every country in the world to be above 0.8 on the HDI, because that means that there's a high quality of living. Anything below that, particularly anything below about 0.6, is a really pretty poor quality of life. So we don't want that. On the y-axis, this is the number of Earths required if everyone in the world were to live like that country. In other words, this country up here, not sure who that is, or let's pick on this one, the very highest. That's probably Kuwait. This country, if everyone in the world lived like they did in Kuwait, we would require 9 planets worth of resources to meet those needs. Obviously, we don't have 9 planets, so that's a problem. The trick, of course, is that this is the golden zone right here, right? Where a country is both high-level development, but also under the world's biocapacity. There's no countries there, not a single one. This is a big problem, that there's not a single country in this quadrant right here. In fact, the only countries that are below the world's biocapacity all have a much lower level of development. And ethically, that's not acceptable. We're not okay with this reality of these countries being so poorly developed. Now, there's a few that are kind of close right here. Ironically, the one that's closest, I think, is Cuba. It's one of these green dots right here that's closest to having a high level of development and a sustainable level of development. But the problem is that as countries develop economically and as their well-being goes up, their demands on the earth go up, which makes sense intuitively, but has to change. It's not sustainable over the long run for us to do this. And this is one of the more fundamental ways of thinking about these kinds of environmental challenges, that we have to decouple this kind of pollution from economic growth. The ways that the demands we make of the earth are not sustainable in this capacity. Here's just a graphic of what if the world's population lived like what? So if the world lived like Bangladesh, this is the amount of resources that they would consume. Easy to accommodate on a global scale. India, etc. China is just about at a 1. So China just about uses a whole, if everyone in the world lived like they do in China, we're just about right. Maybe a little bit over asking. Of course, the problem in the US is 4 planets. If everyone in the world lived like we do in the US, it would require 4 planets worth of resources to keep up with that. This is a problem. Also of interesting to note, France, which has an equal quality of life to us in the US. I don't know, being a French major in undergrad, I might say better. But nevertheless, well, yeah, there's still 2.5 planets, which is bad. But it's a whole lot less than actually the US is, which I find to be particularly interesting to look at that example. So I'm really curious, looking forward to seeing, I guess by now, by the time you watch this, I have seen what you put on the homework assignment for a footprint calculator. Make sure that you have done this. This is not only a great assignment, but I think a fascinating way to look at what our personal impact on the environment will be. And I think you will be shocked to see the size of yours. I am going to show you mine. The last time I took it, these are the results from my ecological footprint. So even me, who is the green guy at Houghton, I spend my whole life talking about how we need to be more environmentally sustainable. I work hard at that. I spend a lot of the money that I have, a lot of my income goes towards reorienting my life to be more sustainable, to use less energy, etc. Nevertheless, I still use more than 3 Earths worth of materials. Everyone in the world lived like me, it would take 3 planets in order to accommodate those needs. For me, my biggest consumption category, pay attention to your consumption category. My biggest one by far is mobility. Living in a rural area, we drive a lot to get to places. That's unavoidable. We don't have any public transportation here to speak of. Now, I have switched to an electric car, which has helped that tremendously, but we still use the minivan for some transportation as well. I also have 1 or 2 flights a year, sometimes for business purposes. I still do some vacations where I fly to get there. And the biggest chunk by far of my whole ecological footprint are the flights that I take. The second biggest chunk for me being food, that there's still a lot of impact coming from food. So pay attention to these and think through, like, what are the areas that are really your biggest impact? And is there anything that you can do from that? All right, that's it for today. Thank you, everybody. I hope you found this really interesting. Our next focus, our next unit, we're going to dig into specific topical issues that we're going to look at and really dig into a lot more specific issues.